Okay, please welcome the group from Madison County High School.
We're here the factory farming pro side. Factory farming started in 1926. It was not by design, but rather of an over-delivery of 450 chickens to a small farm on the Marble Peninsula. Just kidding, guys. That was last year's project. I'm Mr. Dylan. This is Claudia Gahn, and this is Millie Rice. We are representing Madison County High School Blue Ridge Virtual Government School Class of 2018. Our class decided to use soy milk to replace the possible missing flavonoids that are produced by the AADL gene.
In this experiment, we tested the effects of the AADL gene or the absence of it. Because the AADL gene is key to the production of flavonoids and antioxidants, in our experimental design, we wanted to create a solution that would make up for the lack of antioxidants in the mutant-type plants. At first, pomegranate or blueberry juice was ideal, but with further research, it was decided against because of its acidity and added variables such as sugar. We then decided on soy milk because of its relatively neutral pH, lack of added variables, abundance of antioxidants, and another research study we found. In that research study, 3 lettuce plants were administered either soy milk, coconut milk, or just water. Of those 3 lettuce plants, the one administered soy milk not only grew the tallest, but also at the fastest rate. So we came to our hypothesis, which is if half of our experimental group is administered a 100% solution of soy milk, and the other half of our experimental group is administered a 50% solution of soy milk and water, then the mutant plants will grow at a faster rate than the control group and the wild type plants.
We applied by putting our solutions in a beaker. One beaker had 100% solution of soy milk, while the other one had a 50% solution of soy milk and water. We put 1 milliliter of solution in a pipette and gave each plant in the experimental group 1 milliliter of either 50% or 100% solution. We gave our control group just water. We were always careful and made sure we never cross-contaminated. This is the calendar that we put on our website. On this calendar, we tracked any time that we did any applications, thinning, watering, observations, or other components of the experiment. We planted our seeds on September 28th. We tried to apply and water on every Monday and Friday. The last time we watered was on the 9th of November, and the last time we applied was on the 6th of November. And we thinned on the 7th of October. This is how our schedule went.
This graph is of the widest point on the rosette leaves. On the x-axis is plant types. On the y-axis is the measurement in millimeters. The wild type control, it has the widest rosettes at 7.16 millimeters, followed by the mutant experimental at 6.66 millimeters. Oh, I'm sorry, the control. Then it's the mutant experimental at 6.57 millimeters. Then the wild type experimental at 6.48 millimeters. The rosette width was not altered by the soy milk because all of the rosettes are around the same size.
We also observed the shape of the rosette leaves throughout this experiment. As you can see, on the left are the wild type plants, and they show a thinner and longer leaf than the mutant type plants. And on the right are the mutant type plants that have a shorter and thicker leaf than the wild type plants.
Bold height growth rate was greatest in the wild type control group. From November 2nd to November 6th, the wild type control group grew 90.6 millimeters, while the next biggest grew 78.3 millimeters. From November 6th to November 9th, the wild type control grew 74.1 millimeters. And the next biggest in that time period was 39.7 millimeters. By this data, it shows that the wild type control had the greatest growth rate out of all the groups.
This picture is of two approved Arabidopsis plants. On the left is a wild type experiment, and on the right is a mutant experiment. We took this picture to show the difference in coloring of the rosettes. As you can see, the wild type rosettes are much darker than the mutant. We believe this is because of the flavonoids produced by the AADL gene. Flavonoids make plants like pomegranates and blueberries have a darker color. Because the mutant plants do not have as many flavonoids, they are lighter green.
We also observed the amount of seed pods in each plant by counting the amount of seed pods on each bulb of each plant. As you can see, on the left are the control group plants, and on the right, the experimental group plants. Overall, the wild type plants produce the most amount of seed pods, and of those wild type plants, the control group produced the most amount of seed pods.
In conclusion, our hypothesis that if we administer half of our experimental groups a 50% solution of soy milk and water, and the other half of our experimental plants a 100% solution of just soy milk, then the mutants will have a faster rate of growth than the wild type plants in the control group. Was not correct because of the wild type's larger rosettes, taller bolts, darker color, and larger abundance of seed pods.
The Madison County VRVGS Class of 2018 would also like to thank all of the VRVGS teachers involved with this project. Thank you to Mr. Caraway and Ms. Sutton, and a special thank you to Dr. Lally. Thank you for all of your inspiration and help throughout this project.
That you wouldn't have a ton of like variables that could impact it.
Yeah, well, that was one of our, if we could improve this experiment in any way, we would try to have a more soy-based independent variable, but we tried to get the most soy-based and organic solution possible so that we could get the best results.
So you said that you had added 1 milliliter of soy milk solution every time you added the variable, or did you say differently?
Yes, it was a 1 milliliter amount of either the 100% solution or the 50% solution, depending on which half the experimental group it was.
Do you think if you added more soy milk, you could then get a bigger difference in the plants?
Yes, we wanted to, if we could have improved this experiment, we would have wanted to apply more and earlier.
How does soy milk naturally occur in nature? Why did you choose it?
We chose soy milk because it had antioxidants and because there was no AADL gene to help produce antioxidants in the mutant type plants. We wanted to kind of have a substitute so that the mutant plants could be as successful or even more successful than the wild type plants.
Did you say that your control group was there was one you said like 50% solution, 50% water?
No, that was our, okay, so we divided we divided our experimental group into 2 parts. Half of our experimental group received a solution of just soy milk, and then the other half of the experimental group would receive a solution of 50% water and 50% soy milk.
Were they both the same type of plants?
They were both Arabidopsis.
No, I'm asking, like, were they both wild types or were they both new ones?
Oh no, there were 2 control and 2 wild type groups both halves.
Hey, guys.
So this is not, I'm not trying to contradict you, but you guys, it's like you thought you were gonna substitute it, and you'd see a difference, but if you look at your, maybe I'm wrong, if you look at your mutant experimentals versus your controls, like, it looks like, wow, stupid. Hold on, give me a second. It looks like, well, about the same. Okay, never mind, I think I'm being dumb. I was thinking that it ended up looking like they did too.
They missed it.
Yeah, so it looks like that your wild type had, there was a big impact. Right, really reduced the whole finding, your wild type, and you didn't
Yeah.
do anything.
Yeah.
Okay, whatever, yeah.
Hey, guys,
Go back to the picture.
we're finding something out here.
The picture for this. That one. So those leaves look really big and curly on the mutant, as opposed to the mutant control that was like just like that.
They were taken at different, like very different. Yeah, see, this was taken at, on the 30th of October, and this was taken on the 6th of November.
Other,
Well, see, we saw that in our hypothesis, we wanted to help the mutant type plant, specifically be as successful as the wild type, but as you can see, the wild type had a much taller bolt height than the mutant type.
We didn't see like the big negative drop between your two groups, like you saw, like when you added the soy milk, you saw a huge difference, and if you look at your mutants, you don't see that at
That's
all.
actually interesting,
Yeah, I think that's really interesting.
because you had a different response. Right? Typically in the wild type, you see this, suppression in bull type, and no effect or even a little improvement of some of the data. So that's a different response. So it's
Thank you.